So what I'm hoping to do this time is to show you a compound burning, because compounds are made of two or more elements chemically bonded, and when you've got not just one element but more than one element in a compound, then what I want you to learn is that the individual elements will combine with oxygen and make for you the various elemental oxides of the elements that are within the compound. Now I can show this fairly easily if I have natural gas and I burn natural gas. So here I've got a little burner, and if I turn the air hole closed and turn the gas on and light it, then that is natural gas burning. So you can see there, I hope you can see there, here where my hand is, that's a flame, and from that flame I've got various things coming off. Carbon dioxide, soot, that's carbon monoxide. And really what I want to focus on is the products of combustion. Like, we know we've got methane coming through this black gas hose. We know we've got methane coming through there, CH4. So CH4 comes down this black tube from the gas tap, and the gas goes up here and burns. Now if I open the air hole and get more oxygen, then I get this roaring flame. Now the roaring flame has only got carbon dioxide and water coming off it. Now to prove there's only water and carbon dioxide off it, I can put it in this is a funnel, right? It's a special funnel called a Thistle Funnel, and we've made the apparatus up ourselves. And in here, I don't know if you can see, the Thistle Funnel leads into this tube here, boiling tube. The boiling tube has in it a longer stem coming from this delivery tube. The delivery tube leads to a longer stem, then there's a shorter stem coming out, and then another tube here. Now, what I want to do is I want to suck the products of combustion through there into this tube. I want to cool the tube down with cold water, and I'm hoping to collect in there some droplets of water from the flame to show you that flames are wet. Water is often present in flames. I'm hoping to catch it there. And then carbon dioxide, I'm hoping to show you in this tube by having some lime water. If I get some lime water into this tube, and then if carbon dioxide is present here, the lime water will pour some away because I don't want it bubbling over. Then the lime water should go and turn white as a consequence of the calcium carbonate, which is a white precipitate. So that's the apparatus. And how do I get the products of combustion to go through it? Well, I need to introduce you to this. This apparatus here is a suction pump. So it's just a tap, basically, a tap with a side arm. I hope you can see that, the side arm. If I turn it on, as water goes down there, there's a suction here. Now, you see my finger is over the suction, and if I pull it out, I'm hoping you can see that my finger has been sucked there. There's a little round mark on my finger to show the suction of this. And what I'm going to do is to put this onto the suction like that, so that the suction is transferred to this tube here. See, look, suction Okay, so just turn it round, suction, I'm going to put on the end of this here. And immediately you can see the lime water is being sucked. Sorry, the air is being sucked from here through there. Now, we need to put some water in here. So if I get water, I put water into the beaker to give me a cooling effect. Then I'm ready to put my burner there and do the experiment. So here I've got the gas burning, methane burning. The suction sucks everything from the flame through the apparatus. As the suction works, I'm hoping that water vapour, that steam from the top of the flame will go into this tube. It will be cooled down by the water that's here where my hand is. It's unfortunate that the clamp is on that side. I don't think my technician knew which side the clamp would be, because different labs in my school have suction pumps and different sides. I've had to have it that side to give me the suction, and that's why the clamp gets in the way. But this is just cooling that down. Now let me just take this apart. Here, this is the lime water. Now, that's the lime water. I want you to see that that lime water is milky. I don't like the word milky. Definitely not cloudy. Do never ever use the word cloudy. It is a white precipitate. Now, white precipitate means that it has formed a white solid during the reaction. I want you to say that. Lime water, white precipitate, is what proves that you had carbon dioxide bubbling through it. And we just had it bubbling, and that's why it's bubbling. And now if I put this back, because I need it back to give me the suction. So the suction happening here, I'm hoping I can show you that I've got drops of water collected. Now I can see I've got drops of water. I can see the condensation going on. However, have I got enough to show you? You'll have to wait and see. Are you in there next? Yeah, I only need... I'm only here, yeah, I'm only here 2 more minutes. So I've got this beaker here, and I can stop the experiment and show you, which I'm going to do. Sorry, a colleague of mine has come in, wants to use the room. So these things happen. If I turn off the suction, you see the bubbling in that tube of lime water stops because the suction is off. Disconnect the suction, disconnect the apparatus. It's a bit hot, so just going to use a cloth to disconnect it there. Turn it round. That was the lime water tube. This is the tube that was being cooled by the water. Can you see? There is a small quantity of colourless liquid at the bottom of that tube, and that colourless liquid, believe it or not, is water. So water vapour from the flame has been cooled to make this water. I can prove it's water by adding it to anhydrous copper sulfate, watching the copper sulfate go from white to blue, or I could collect more and boil it at 100 degrees, freeze it at 0 degrees, and that would prove it's water. But you're just going to have to accept it is water, and that's because I've told you, you're going to have to trust me. That is water, it's a product of combustion. So, what am I hoping that you learn from that? I'm hoping that you learn when we have compounds, that the compounds will burn, and the elements within the compound make the oxides, the elemental oxides that are present within the compound. Now, last lesson, I burnt the elements on their own. And I just want to go through some equations with you. I hope you can see that. Equations there. I'm just a little worried about whether you'll be able to hear me when I get over to my board. So let me move my phone a bit closer to the board. And then I want you to know the following. Last lesson, element with oxygen makes element oxide. So magnesium with oxygen makes magnesium oxide. To balance it up, the two oxygens need a big 2 there. Magnesium solid, oxygen gas, magnesium oxide. That was the white ash. The white ash you saw in the recordings that you've hopefully already seen. Right, sodium. So what would the balance equation be for sodium when it was reacting with oxygen that you saw? Well, sodium plus oxygen gas would make, believe it or not, sodium oxide. Now the formula of sodium oxide, Na2O solid. Now that's not balanced. Look on the left, 1 sodium. On the right, 2 sodiums. 2 oxygens, 1 oxygen. We need to balance it. So to balance it, you put a 2 there, that gives you 4 sodiums, 2 lots of oxygen, O2, that's okay. That is what happens when sodium burns, it makes sodium oxide. When copper burns, it makes copper oxide. Balance it up, you need a 2 there and a 2 there. I hope you can follow the balancing, but the extra thing I want to teach you is that when you've got metals with oxides, metal oxides, then your metal oxides are the bases of the world. Now, bases is a term I'm going to explain in a future video, but bases that dissolve are the alkalis of our world. So the important thing to learn from that is that metals when they burn give you bases, and the soluble bases are the alkalis of the world. And what about non-metals, finally? Well, we burnt sulfur. Sulfur and oxygen made sulfur dioxide gas. Phosphorus is P4, by the way. Small molecules, 4 phosphorus atoms per molecule. P4 plus oxygen makes P4O10, which was a solid, and to balance it, we need a 5 there. So phosphorus oxide, sulfur dioxide, and carbon, if you burn it, making carbon dioxide, like that, are all acids. Can you see, it's the opposite of bases. Metals burn to make bases. Non-metals, when they burn, make acids. So the non-metal oxides are acidic, and if they dissolve, they make the acids of our world. So really quite important, I think, that you know where the acids and alkalis of our world come from. And they come from these elemental oxides. Right, we'll leave it there. Catch up with you next time.